One, yeah, okay, perfect, thanks. So I guess we can start. So first of all, good afternoon. Thanks for having me. My name is Delabassee. I work at Oracle. It's not the first time that I attend this conference. I've been here multiple times, but the last few years I couldn't make it. So today I'm going to discuss about FN project. And before we start, just by show of hand, how many Java developers do we have in the room? Okay, so quite a lot. JavaScript developers? Yeah, don't be ashamed. Go developers? Go? Nobody? Kotlin? A few? Something else? Like what? Sorry? Okay. Okay, good. So as I told you, my name is David Delabassee. Despite my French accent, I'm not French. I live in Belgium, in fact, where I work for Oracle. I do report to HQ in California. Before we start, I just want to share a few information about Belgium because it's a very hot country. It's a very small country. In terms of size, I think it's 2 times smaller than Latvia. But we do have 5 more times inhabitants than in Latvia. Something that we are quite proud in Belgium is the food. We are very good food. So the first kind of food that we have, Belgian beers. We have over 1,600 different kinds of beer. For a small country, this is quite a big deal. Not only that, Belgian beer have been put by the UNESCO on their cultural heritage list. So that's something that is recognized at the global level. Next to that, we have the Belgian chocolate. We produce around 22 kilograms of chocolate per inhabitant. And it's one of the best chocolate in the world. And then there's this. The French fries, yeah. If you look on Wikipedia, if you have a lot of time, you look on the fries page on Wikipedia, there is a whole section that talks about the French fries. So there is an ongoing battle between France and Belgium about the ownership of fries. And clearly that section on the Wikipedia page clearly says that the fries are coming from Belgium and not from France. And finally, we have the Brussels sprout. Anybody enjoy the Brussels sprout? Oh, that's quite a lot. Well, I'm sorry for you. I have my own theory, and basically I'm pretty sure that the Brussels sprouts are not coming from Belgium, but they are coming from France instead. So, anyway, let's discuss about Project FN, an open source container native fast platform. So before we do so, just want to set the stage. So we're talking about a fast platform, a function as a service platform. So at the heart of a fast platform, we have a function. A function is basically a small piece of code with a very well-defined job. It has one job and it should perform that job very well. It's not a function as we have in Mathematica, in the sense that a function most of the time will have an input to trigger the function. It will also have an output most of the time, and it might also have a side effect. So the thing that you, as a fast user, as a fast platform user, will focus on, you will just focus on writing function. So basically, the function is that small piece of code with that well-defined job, and that's all you will have to take care. Next to that, we have this as a service piece. That's basically the compute platform on which your function will run on. And the idea is that it's basically someone else that will have to manage that compute element. So it's someone else's responsibility to manage the platform in terms of security, in terms of provisioning, in terms of scalability, and so on and so on. So you as a user will not have to do and deal with the platform. You will just consume the platform and nothing else. Now, something which is quite key also about the function is that the function should be stateless, and they are very well defined and they are short-lived. So that basically gives us the ability to easily scale the function. Something that you will not have to take care in your code because it will be handled by the platform at the fast platform level. So why would you want to go towards the serverless architecture? Well, given that you, at the end of the day, will just write function, you will just focus on your code and nothing else. So it should be easier for you at the end of the day. You just focus on your code and you don't have to deal with any of the underlying technical plumbing of the platform. It also provides you a more powerful models because, again, you're just focusing on writing your code and all the low-level stuff, it's not your job. It's someone else's responsibility. That also means that at the end of the day, you should have a more rapid development cycles. You will see basically in some of the demo that I will do that you can quickly get up and running. You write your function, you test your function, you deploy your function. And again, all the underlying technical stuff from the platform, it's not your job. It's someone else's duty. Now, there's also something which is quite key about a fast platform, and that's the economic angles. Given that we have functions which are by nature very short-lived, that basically means that it gives the fast platform provider the ability to do new way of billings. So we can, for example, do billings in very small increments, in tens of milliseconds or 100 milliseconds. And the basic idea is that you will only be charged when your functions are running. So if your functions are not running, you shouldn't be billed. You shouldn't pay a cent for that. So the economic angle is something which is quite important as well. Having said that, this is a technical session, so I will not talk about that anymore. So some time ago at Oracle, we started to work on our fast platform. And we asked ourselves, okay, what should the ideal fast platform have in terms of characteristic? So the first key point is that we think that it has to be open source. Given that we are relatively late in the game, if we have a solution that is proprietary, there is no way we could gain traction with that. So being open source from the beginning was a key aspect for our fast project. We also want to be very approachable, and we have a very strong developer focus. At the end of the day, given that we are talking to developers, we need to make sure that whatever we do match their need. Whatever we provide is something that they can easily combine with their existing tools. So the platform should be very approachable. It should be easy to get started. But on the other hand, if you want to see and get access to stuff running under the hood, that's something which should be also possible. So we don't want to do any black magic. So you will see that we have a very clean approach regarding that. Something that we also wanted, that we think was important, is that we want to leverage the Docker ecosystem. And you will see that FN is leveraging the Docker ecosystem, but we also provide all the abstraction, so you don't necessarily need to know how to use Docker if you don't want to. So being container-based was a key aspect. But regarding the scheduler, we want it to be independent of the scheduler. So you should be able to use FN on top of Kubernetes, on top of Apache Mesos or Docker Swarm. Having said that, it's clear that the winner in that space is Kubernetes. So Oracle, at some point in time, will have a managed services offering based on FN, and we have clearly said that we're going to use Kubernetes. But if you want to use something else, given that everything is open source, there's no specific aspect which are tied to Kubernetes. So you can take FN and run it on something else. One of the key aspects is that we also think, when we started, that our fast platform should be language independent. So if we are talking to Java developers, we need to provide them Java tools. But if we are talking to Go developers, well, we need to provide them the tools that they're using. That means Go tools. If we are talking to JavaScript developers, well, if you are asking a JavaScript developers to develop in Java, something doesn't work. So you will see that basically we are language independent and we have the ability to easily add other language. And last but not least, we also think that our fast platform should be platform independent. At the end of the day, you will likely use FN in a managed cloud services, but this doesn't preclude you from taking the bits, given that everything is open source, and run it on premises. That's something that might be perfectly valid in some use case. Obviously, if you are running FN on premises, you will lose one of the key benefits of a fast platform, in the sense that someone in your company will have to manage that on-premises FN. But if you understand that, that's perfectly fine. And last but not least, you can also run FN on your laptop. That's typically something which is very convenient for development. So we take basically what's running in the cloud and we run it locally. So it's not a simulation environment or something like that. It's the same bits, but at a smaller scale. So it's something which is very convenient for development, testing, and so on. So these were basically our goals. And the outcome of that is a FN project, which we will discuss in some details. So, first we have to talk about the function, which is really at the heart of any fast platform and also at the heart of FN. So in FN, functions are basically wrapped as Docker image. So you write your code of your function, and FN will make sure that it's wrapped as a Docker image. So whenever it's invoked, we will basically spin up that container, run your function code, and there you go. So the function gets its input via std in, it produces its output via std out, and it can use std error if something goes wrong. The key thing here is that you don't have to do anything at the Docker level. So let's look at a quick demo to show how it works. So I will start by writing a small hello world function, and I will do that in Go. This is the most basic function that you can have. So this is my function. You see that there's nothing specific to FN. It's a pure Go code. So what I'm going to use is I will use the CLI that is provided by FN to basically bootstrap that function. So for that, FN, and well, let's build it. No, I will first do an init, sorry. FN init. So you see, it has found a Go function, so it assumed that we want to use the Go runtime. It makes sense. If we look, what has been created, just one file. And this is basically a configuration file that has some metadata for our function. So that's the name of the function, the version of the function, the runtime to use, the entry point, and so on and so on. Now we can run this function. FN run. Maybe I should do a verbose. So running my function basically means that we are asking FN to take the code of the function, wrap it into a Docker image, and the final step is obviously to run the Docker image. And this is the result of my function. So this is basically how it works. So let's go back to the slide. Now, in terms of architectures, there are two key elements that you need to be aware of. That's the FN server. Here I have a FN server running on my machine. That's really the server that will run your function. If you want to scale, if you want to have high availability, you obviously need to have multiple FN server. If you have multiple FN server, you need to have an FN load balancer in front of it. The FN load balancer will do intelligent routing. So, for example, there is an incoming request for a given function. The load balancer knows that that server has already a container running for that type of function, so it will route the request directly for that towards that server to just save times. Now, if you are using a managed service based on FN, it's not something that you have to be aware of. You just have one URL, that's basically where you will deploy your function. And it doesn't matter if there is just 2 FN server or 100 FN server, everything should be, again, managed by the fast platform provider. So that's why I will not spend a lot of time about the different elements that we have in the architecture. As a user, you will typically use the FN CLI. So we have already been using the FN CLI. So you will use the CLI to bootstrap a function, to test a function, to run a function, to deploy, build a function, and so on and so on. So that's basically the main tool that you will use as developers. Now, FN also provides a bunch of FDKs, function development kits. So those are basically SDK that helps you to write functions, so that provide additional capabilities. And we will look at some of the capabilities that are provided by the Java FDKs later on. And one of that capability is FN Flow. We'll discuss FN Flow a little bit later. So let's look at some Java code. Before we do so, I will just remove that Go function, and there is another way to create a Go function. So fn init, I specify the runtime, and I give my function a name. And this time, if we look, we have a few more files that have been created, like a test.json. So that's something that is provided by fn, is that you have the ability to directly test the function. So here we have a simple Go function that has been created. So it's the func.go. So it's again a function that gets an input and produces an output. So we can run that function. Again, we already saw that. Message hello world. We can test the function directly using the CLI. So the test is basically this test.json file that you see at the top, and it has two test scenarios to test the function, and those tests are pretty basic. So this is what we provide out of the box. So we bootstrap a very simple function, and we provide the basic test for that function. And obviously, you as a developer have the ability to extend that. So if you pass it Johnny, you expect to have hello Johnny as an output, and if you don't pass it anything, you should have hello world as an output. So let's see. Now we'll do fn init, but this time we'll switch to the Java runtime. Let's call that function. So by the way, the timer doesn't work. So let's look at what we have here. We have a class, hello function. So this is again the skeleton of a simple Java function. We have a second class which happened to be a JUnit test. So that's something that we provide. Given that we're in the Java ecosystem, we think that it might be very useful to leverage JUnit to test your Java class. So the core idea with FN is that if you are a Java developer, we will provide you the tools that you are using today. We don't want to impose any new tools. And you see here that we do have a pom.xml. So basically what we have created a function with a test, and it's basically just a Maven project. So let's see. This is super small here. So we have the source. This is our Java function. You see that it's pure Java code. I mean, it's a very basic class. It has one method. The method has a string in input, and it produces an output. There's no interface. It's very simple. We also have the JUnit test. So that means that run hello function. So we should be able to do this, and if it works. So our test works, and obviously if we change the class itself, if we run the test again, it should go red. And it goes red, everything is fine. So, obviously, I can still do an fn run my function. It works. I can pass it some payload. Oops. And you see that I pass it David, hello David, it works. So the thing that I'm doing here when I do an fn run is basically I'm using my local Docker. Obviously, at the end of the day, this is not what we want to do. We want to deploy our function on an FN server in a managed service running FN. To do that, I need to create an application. An application is just a grouping of functions. So I will create an application, fn apps create, and I will call it Riga. So fn apps list. I have 3 applications, and now I can deploy to my Riga apps, and I want to deploy my Duke function. And I always forgot that guy. Okay. So my function now is running on my FN server, which happened to be local, but I'm not using my local Docker anymore. So if I look at the routes that I have in my Riga app, I have 1 route. So that basically means that I can, for example, I can curl my function through the network. And now I'm hitting my function through an FN server. I can also use FN call to do that. So I want to call in the Riga app. I want to invoke the Duke function, and let's say that I will pipe in some stuff. Oops. And you see hello Riga. So it works. So let's go back here. Well, this is a very simple method. It has a string in input and it gets an output. We can probably do better. Before we do that, let's look at the POM. It's a POM. So that means that I can basically use it to import external dependency. Yeah, Jodamoni. Oops, import. Okay, so now if I go here in my method, big money. I'm very good at finding very stupid example. So I'm using Jodamoni. That is coming from the outside. I have an error here because my name is not defined anymore. Well, it doesn't matter. Let's get rid of it. Now, let's invoke the function. I will. The image is being rebuilt, so we are using Docker for that, and you saw that we are using Maven, in fact, to build that image. I have an error here. Anyone knows what went wrong? Yeah. So I can fix the test. What? Well, I will do that because I don't want to spend my time in rewriting the test all the time. So skip test, yes, should be okay. And you see here the result of the function. So hello, you've won €8. So I'm indeed using Jodamoni that has been imported via my pom.xml. So again, this is this idea that as a Java developers, you just want to continue to use what you are using today, even if you are developing towards a fast platform. So let's look at something else. So this method gets a string in input and it produces a string in output. This might be useful, but let's pretend that we have a person which has a last name and a first name, right? So I need the default constructor. And I also need the getters and setters. Okay, so we have this person type now. So what we can do now, we can say, okay, instead of getting a string in input, well, we are getting a person object. So it's a Java object, right? So here, what we would have to do, input get first. Get last. So this is indeed a Java object. Now the thing is that I'm telling my function, okay, you will get that Java object, which is a person object. Obviously, when I invoke my function, I will have to pass it that person type. For that, I'm going to use simply JSON. So we said that we have a person has a last name, and a person has a first name. So that is basically a person. So what we will do, we will basically pipe that payload to our function. Here I'm running my function locally, but obviously I can, if my function is running on a FN server through an HTTP endpoint, it would be exactly the same. So let's invoke the function. FN run should be okay. And you see that each time I'm changing the function, the version number of the function is bumped. So we are at version 3. And you see here that, so I've passed it my JSON payload, and in the Java code, what I got was directly a Java object. So this is something that the FDK provides for you. The coercion, the input and output coercion between JSON payload and a Java object is provided for you by default. Under the hood, we are using Jackson. You have the ability to configure the way we do the input and output coercion is the one that we are providing by default, doesn't match your needs. And obviously, I can also do this. So I can say that, for example, well, no, let's keep it person. My method gets person in input, and we will produce a person object in output. So let's just send that guy back. And here, we just say that we want to anonymize the name. Set last name, yes, should be okay. Okay, and you see that the only thing I'm doing here, I'm just using Java object, but what I do get, in fact, is really a JSON payload, right? So this is one of the capabilities that is provided by the FDK. So we first produce a Maven project, then we are giving you JUnit support for free, and then we also provide input and output coercion that you can easily use. So how much time do I have? Sorry? No. How much time do I have? Because the timer doesn't work. Still 15? Okay. Okay. So we saw that we support Go. We obviously support Java. We also support Python, JavaScript, and so on. If that's not enough, you have the ability to add your own language. And that's what I did for Kotlin. So if you do fn init, you know the drill. So fn init, you want to use the Kotlin runtime. So we still have a test file to test our function, and if you look at the code, we indeed have a Kotlin function. So let's turn that into data class. Oops, I say data. So if we look first at this function, so we should pass it a name object that we will pass using JSON. Riga. Oops. So cat. Yep. So this is my payload that I will pass to my function, and I will fn run my function. So my function will be built. So in this case, under the hood, I will use Kotlin C to create a jar that will be run, and you see that the output is indeed message hello Riga. So this is basically how you can easily either use the language that we are providing to write your function, or if you are using something else, you can easily add support for that given language. So let's go back to the slides. So I told you at the beginning that a function should be stateless. If we want to scale, there's no question about that. You shouldn't have any state in your session. Having said that, most of the time your session will have to deal with some kind of state. So that means that you will basically store the state in an external services. Now, there are some use cases where it makes sense to have the state within a function. And that's typically when you are trying to compose multiple functions together. So the idea is very simple. We have one function that will invoke another function. It gets the result from this function invocation. Based on that result, it will invoke a third function. That function will maybe produce an error. Based on the error of that third function, the first function will do something else. So basically, if you want to chain multiple functions together, then obviously that hover function will have to manage some states. And for doing that, we're providing the FNFlow API. You will see that it's very inspired from the completable feature and completion stage API of Java SE8. The major difference is that it's distributed. The completable feature API, you are basically invoking asynchronous task running within the same virtual machine. Here, you are invoking functions that are running in the infrastructure, and most of the time they will be invoked through the network, obviously. So right now we have a Java implementation, but we're working on the Go implementation, and we'll add support for other language. So to illustrate this, I have this scenario where it's basically a trip booking scenario. So we want to book a trip. So whenever we book a trip, we need to book a flight, we need to book an hotel, and we need to book a car. And finally, at the end, we also want to send an email to the user to tell him that, okay, this is what we have booked for you. To do that, I will use some backend services. So one is written in Java, another one in Ruby, another one in JavaScript, and the email services is written in Python. It doesn't really matter. What we just have interface. Each time we have a booking interface and a cancel interface. The idea is that if something goes wrong, we want to make sure that we cancel what we have just booked. So what we will focus on is this trip booking function that will basically do this chaining. So it will first book a flight, then it will book an hotel, and it will then book a car, and so on and so on. So let's see what we have here. So I have all the functions already here. The one that we want to work is the trip function. And if we look at the routes that we have for the travel apps, we should have multiple routes. And routes list. Sorry. So this is basically all my functions that are running on my machine. So you see that we have a function to book a car, one to cancel a car, and so on and so on. So we will focus on the bottom one, the booking one. So to do this, I will have to use the FNFlow API. And the first thing that I will do, I will basically create a bunch of flow futures. So a flow future is basically an object, a placeholder that will contain the result of a function invocation. So if you look at the first one, for example, so the first one will invoke the flight booking function, and once we have the result will be put in that object. Result, or if something goes wrong, we will also use that object. And we have three flow future objects. So we want to book a flight, an hotel, and a car, right? So we are just creating the flow future object there. It's really here that everything is happening. So basically what we are doing here, we are doing the chaining. So first we invoke the flight booking function. Once we have the result, we have this lambda that will invoke the hotel booking function. Once we have the result from the hotel booking function, we'll finally invoke the car reservation function. And once we have the result of all those functions, we will invoke the email the email services to basically send a confirmation to the user. So let's save that guy. And now let's deploy that function. Let's see if I still... Oops. Yep. So, to trigger that function, I have some payload. So this is basically what I sent to the trip function to try to book a flight, an hotel, and so on. So let's invoke it. So we'll invoke it via its HTTP endpoint. So the app is travel, and the function is trip. Yes. And it works. I will prove you that it works. So I have this tool that that we can use to basically see what's going on. So I will re-invoke the function, and if it works, we should have some activity here. And you see that, yeah. So we are booking a hotel, we are booking a flight, and we are booking the car, and finally we send confirmation mail. This is the same view, but it's probably more visual. So we're booking the hotel, we're booking the car, the flight, and we send the mail, right? So this is how it works. The thing that we're not dealing here is error. So if one of the functions failed for whatever reason, well, too bad. That's obviously something that we can do with the FNFlow API. So this is basically the same chaining. The only difference is that this time we are using this exceptionally compose to deal with error. So if an exception, if one of the function invocation fails, we will basically take this route. And the idea is that if something goes wrong, we want to make sure that we roll back the local transaction. And at the end, what we want to do, we still want to send a mail to the user to tell him that, sorry, we were not able to book your trip. So let's deploy that function. Oops. Okay, let's invoke it. And it's green, everything works. Because my functions are not failing. The good news is that I can make them fail. So each time I will, for example, try to book a car, the function will fail. Yeah, don't use that in production. So let's invoke it again. And this time we should have a different behavior. So we can't book the car, so we need to cancel the flight, the hotel, the car, and we have to send an email to the user. We can have, oops, sorry. We can have a different view. And you see that we were not able to book the car, so we will invoke the cancel flight, cancel hotel, cancel car, and finally we'll send a mail to the user. So this is basically to give you an idea of what FNFlow provides. It gives you the ability to easily define those kind of hybrid functions that will basically chain together multiple functions easily. Okay, so how much time do I have? 2 minutes. Okay. What? Okay, 7 minutes. Anyway, I'm at the wrap-up stage, so I will quickly go over this. So I'll show you basically how you can easily write function using the tool that you are using today. Java, Go, Kotlin, or JavaScript, it doesn't really matter. Obviously, I've looked at really the developer experience. I haven't really written very complex scenario because I don't really have the time. But this is really the core idea. Obviously, we're also providing the management and monitoring capabilities. For example, if something goes wrong in your function, you would like to see what went wrong. That's something that obviously is possible. For example, through the FNCLI, you can have access to the logs. And remember at the beginning, I told you that a function is outputting its error through std error, and that's basically where we can collect that information. We're supporting open tracing, and so on and so on. So, I mean, in terms of management, there are a lot of capabilities that I don't really have the time to discuss here. We provide out function, frozen function, and cold function. I can maybe show you quickly what this means. So if we go back, sorry, bench, if we go back, well, doesn't matter. So fn init, runtime Java, and we'll call this one test. What? Oh, sorry. Okay, I've just created a simple Java function that I will deploy. fn apps list. I will deploy it on Riga. So fn deploy local. The application is Riga, and the function is what it was test, right? And deploy. Okay, I will invoke that function. So but I will time it. Fn call the function. The app is the Riga, and the function is stealth. So you see, to invoke the function, it takes almost 800 milliseconds, which is quite expensive. Why? Because we had to start up basically Docker container. Well, the thing is that once it started, it's hot. So if we invoke the same function again, you see that we have a very good result, 70 milliseconds. And that's something that we're working on, just trying to reduce more and more the startup time of the function. Obviously, given that we are Oracle, we are obviously very involved in OpenJDK, we can do optimization really at the JVM level. So this is what an hot function is. The thing is that keeping a container running might be expensive in terms of resources. Keep in mind that you don't want to pay for when your code is not running. So what we can also do, we can freeze the container. So we will still have a very quick startup time, but we will not consume any resources. So you will not have to be charged for those functions. We also support async function. We are providing a Helm chart that helps you to easily install FN on Kubernetes. We are supporting JAX RS, Spring Cloud function, and so on and so on. So, in a nutshell, FN is a container native. You saw that under the hood we are using Docker. It's cloud agnostic, so it will obviously run very well on top of the Oracle Cloud. But given that everything is open source and there's no locking, you can take it and run it on premises or on a different cloud provider. It's polyglot, Java, Go, JavaScript, Ruby, and so on. And if that's not enough, you have the ability to write your own, to add support for your own language. And really, in terms of developer experience, we are trying to do everything through FN, so the CLI. So in it to bootstrap the function, we can test the function, we can run the function, we can deploy and call the function through the HTTP endpoint. So if we go back to the goal that we set at the beginning, when we started to work on this, I think that we can say that FN is platform independent. It runs on my laptop, but obviously it runs as well on a cloud infrastructure. It's independent of the scheduler. It's Docker-based. I mean, there's no secret about that. It's open source. Everything that is in the GitHub FN organization is basically what we will use at some point in time to provide our managed services offering. But it's an Apache V2 license, so you can take the bits and use them. Obviously, given that it's open source, we are welcoming contribution. So you should really look at that. And also, it's very approachable. I mean that you agree that when, for example, you look at the code of a Java function, there's no specific FN interface to implement. It's pure Java code. So it's something that is very easy to manage and deal with. So I will leave you with some resources, but before we do so, I want to say Paldis. Is that correct? Okay.